In mid-November 2026, a 49-year-old NASA spacecraft is about to do something no human-made object has ever done. It's going to get so far away from us that light itself, the fastest thing in the universe, will take a full 24 hours just to say hello. NASA calls this milestone one light day. A light day is the distance light, or for that matter any electromagnetic wave like a radio signal, travels in 24 hours. To understand how big that is, let's build up to it, starting small. A typical radio signal reaches you from your local radio station in about 100 microseconds, faster than you could ever notice. A radio signal sent from New York reaches California in about 13 milliseconds. Coincidentally, that's almost exactly the same time it takes to cross Europe, coast to coast. Get that? It takes light about 136 milliseconds to do one full lap around the planet Earth. Light could circle the globe about 7.5 times in a single second. It takes a measly 2.5 seconds for the light to make a round trip to the moon and back. People still test this today. It's called Earth-Moon laser ranging, using mirrors left on the moon by the Apollo astronauts 50 years ago. And finally, the longest electromagnetic trip we deal with every single day of our lives is sunlight. It takes about 8 minutes to reach Earth. So the sunlight warming your face right now actually left the sun 8 minutes ago. Now, hold on to that 8-minute number because Voyager 1 signal takes 24 hours one way. Let that sink in. 24 hours just one way. In real terms, the distance is 16.1 billion with a B billion miles, or 25.9 billion kilometers from Earth. Let's put that in perspective. The distance between Sun and Earth is only 93 million miles. That means Voyager has traveled 173 times the distance from Sun to the Earth. It's the equivalent of 33,700 round trips to the moon. It's almost 650,000 times the circumference of our entire planet. And yet, get this unimaginable distance is still puny once we zoom out. The closest star to our solar system, Proxima Centauri. I'll admit, I just love saying Proxima because it's not even close. Proxima Centauri is 4.24 light years away. That's 25 trillion miles. Which means in 49 years of travel, Voyager 1 has covered just 0.0027% of that distance. If Voyager kept traveling at its current average speed, and it's pointing towards Proxima Centauri, which it isn't, but just assume it is, it would take roughly another 76,000 years to get there. Hang in there, Voyager 1. You're almost there. It took 49 years to get this far. NASA's original plan was to keep Voyager 1 operational for just 5 years. It's now lasted 10 times that long, and it's still going. Now, let's pause. How is it still going? There is no sunlight there. Even if there is some, it's practically useless. So how is it powering itself? Here's the thing. Voyager 1's power was never solar. Past Mars, sunlight is already too weak to matter. So instead, it runs on a slowly decaying chunk of plutonium-238. Yes, plutonium-238. NASA essentially sent a miniature nuclear power plant into deep space. That's the real reason she's still alive today. A spacecraft powered by solar panels wouldn't have made it past the first few years of the journey. Voyager 1 still sends data back to Earth. at a flimsy 160 bits per second. For perspective, downloading a single compressed 4K photo at that speed would take about 3 days. A regular 4K movie, forget about it. That's 83 years. As for receiving commands, there's only one antenna on Earth capable of reaching it right now. It's in the Australian bushland near Canberra, called the Deep Space Station 43. One dish. That's a mouthful. That's it, just that one. NASA mostly uses that connection just to gradually shut components down, squeezing out every extra year of Voyager's life. This is what human ingenuity can do. Science and engineering constantly knocking on the doors of the universe for answers. Truly impossible numbers, and somehow we still find a way to tame them. Thanks for watching.